So hi everybody, we're going to review a little bit the Swift server ecosystem and kind of like where it is. So first of all, we need to ask ourselves, why should we even use Swift on the server, right? There's so many great languages for us to use on the server. Why is Swift good? Obviously, it's good for humans, right? For people, for the developers. We love it because it's safe, it's expressive, it's functional. We can do low-level programming, we can do high-level programming. There's a lot to like in that sense. We can also do code sharing, which is really nice for us as developers because we need to write less code. But it's also great for machines, and that's why it's really useful for the server. We'll start with the fact that it has a low memory footprint, which means that you could run more code on less machines, which is great. It's also very fast, right? It's performant. You have easy bridging into C, which allows to do some of these performance-intensive operations. And my personal favorite is the fact that it doesn't have any garbage collection, which means you get a deterministic performance. So if you compare it to other languages that do have garbage collection, you're basically competing with the garbage collector on resources when the garbage collector needs to kick in. So that's why I think it's great for the server. Where is it used in production? There's several main use cases. This is obviously not the full list, but there's several main use cases. IBM has a platform for running Swift on the server. Vapor has a similar platform where you can run Swift on the server. And Amazon has shared with us recently that some of their video processing pipelines are built with Swift on the server. Obviously, Apple runs Swift on the server, anything from small internal tools to large systems that support some of the products that you all know. There's also a lot of open source activity around Swift on server. From left to right, Kitora from IBM is a web framework. Vapor has a web framework. Perfect is a web framework. Node.io is another web framework that is more similar to Node.js, and it's kind of like architectural philosophy. Amazon, that we mentioned before, has open source something called Smoke Framework, which is, I would say, API or RESTful framework that kind of ties nicely into their ecosystem. And Apple has released several open source libraries for the server use cases, including database drivers for FoundationDB, which is an open source database from Apple, to working with Google on gRPC. gRPC is an RPC system that is very useful for talking between services in an efficient binary way. So Apple released the what's called Swift protobuf, which is the binding between protobuf and Swift, but also works with Google on the gRPC, the Swift gRPC implementation. And finally, Swift Neo. Swift Neo is a networking library that is was released actually in TriSwift Tokyo 2018. So last year in this stage, it was announced, and it's in the heart of a lot of these other open source libraries, as they all have some networking needs. So that sounds great, right? It's a beautiful language. It's good for machines, it's good for humans. There's a lot of open source. It's used by big companies, by small companies. Is it the right thing for you? Should you be, not using Ruby on Rails or Node.js or Java or Scala, or whatever it is you're using on the server, and move everything to Swift? The answer to that, of course, is yes. But there are a few things that are still in motion. And I wanted to highlight some of these things so you know what you're getting yourself into. So we'll start with database and storage drivers. When you write server applications, it's really nice and it's very, it's pretty mature at this stage to write the stateful part, right? You have, you're receiving maybe a request, whether it's RPC, whether it's RESTful. You can do the stateless part pretty well with all these web frameworks that we mentioned. But at the end of the day, you need to store the state somewhere, right? So you need to go talk to some database or some other, maybe a queue system or whatever it is that you're doing, right? The state of the database drivers is a mixed bag. On one hand, there's a lot of database drivers. I think this is where the fact that Swift binds into C shows its value. Almost all of these databases, almost all of these storage systems have C clients. So you can very simply wrap that right in Swift, and there you go. But what's still missing, or what's still not consistent, is the fact that a lot of these database drivers have what I would say a non-consistent concurrency model. So for example, if your web application is blocking and the database driver is non-blocking, you know, it gets a little strange from a programming model. Or vice versa, if you're using a non-blocking web framework, but the database driver is blocking, then you know what's the use of having like a non-blocking web framework? So we would like to see a little bit more consistency around that, even not just between the blocking and non-blocking, but also when you talk about non-blocking, what style of non-blocking? What's a programming model, right? Is it callbacks? Is it futures? If it's futures, which futures? All those different options that are in front of you. The other thing that is very important for server developers is observability, and you probably heard this before. This is less relevant for small applications, but it's really, really, really important for large systems. So the kind of systems that you write or you develop at Apple and some of the other shops, larger shops, you know, those things really come into play. What does observability mean? It means the ability to reason about your system as a whole, not just one component of the system, but the whole system. And we typically, when we talk about observability, we talk about three axes. We talk about logging. Logging is very simple to understand, right? You basically emit some textual information. This is what happened, and that shows up somewhere, right? Maybe a file or maybe some server. When you have a large system, you have a lot of components that write log entries. You do want some consistency in that, because you typically want to send that to something that then indexes that, and then you can search and you can reason about your system. So you want your different libraries and the different components of your systems to all log in the same way. So that's very important. Similarly, you have metrics. Metrics is just like logging, but instead of textual information, you usually track some kind of numeric information about your system. That can be things like performance information or different counters of what's happening in the system. Again, you want all of these things from all the components in the system to go to one place where you can reason about your system. And finally, tracing. Tracing is the ability to basically trace or track a certain request as it comes through the system and flows through the different components of the system. So let's imagine that you have a request that came from a browser or from a mobile device. It hits some kind of a gateway, it goes to some component, that component puts it in a queue, some other components dequeues it. How do you know what happened, right? In a large system, it's pretty difficult. So we use tracing for that. And usually the way you do tracing is you do it by passing some kind of identifier of the request. That can be in HTTP headers, it can be in other ways. It can be an envelope of a payload that you put in a queue. But you want to carry that request ID or identifier throughout the system to understand what's going on. The other thing we want to see evolving is the server developer experience. We use Xcode the same way that application developers, like mobile developers, do. But we also use SwiftPM. It was mentioned actually in the previous talk, so that was great. Those things are not as integrated as we want them to be. So today we have the split experience where part of the time we're in Xcode, part of the time we're on the command line. We would love to see that a little bit more integrated, and the teams at Apple are working on that. Another tool that is very, very important for us is Docker. Why is Docker important? Because we develop on Darwin-based systems, our MacBooks. But we ship, right? We run in production on Linux. So it's not necessarily even the same code. Some of the code is split. You have a Linux implementation, you have a Darwin implementation. So how do we as developers, know what's going on or emulate what's going to go in production? It's important for us to be able to do that, and Docker is an extremely important tool in that, and we want to see all three of these things integrated. That leads me to the server working group. The server working group was founded in 2016. It was an initiative by IBM, Apple, and Vapor. We came together to try to address some of the needs of the server side. We have a separate but very similar process to the evolution process. The main difference is that the evolution process ends up in changes to the Swift language itself, right, or the standard library, or other tools that are related to that. For us, we end up with certain libraries or frameworks that you then pull into your projects using SwiftPM, but it doesn't end up in the language itself. The first phase was around networking, security, and HTTP. It was concluded with the introduction of Swift Neo that covered those concerns. Right now, we're in the second phase of it, which is focused on the ecosystem. So growing the system, adding more libraries, filling the gaps of what is required for server developers. Our priorities are, unsurprisingly, mirror the things that we talked about, right? So database drivers, focus on distributed systems, microservices, event-driven architecture, all the observability part goes into there, and of course developer tooling and production readiness. This is what the incubation process looks like. Basically, people make pitches the same way they do for standard Swift in the Swift forums. There's a server category. There's some voting going around the pitches. Then they get to a proposal phase. And from the proposal phase, this is where we diverge a little bit. We go into this incubation process. And the incubation process basically means that a library can be accepted at three different levels: sandbox, incubating, or graduated. Sandbox and incubating typically means that the library is maybe not used by enough people, or maybe the team that is supporting it is not big enough. And graduated means that it's recommended for use in production. It means that we think that both the quality and the longevity of the library is where it needs to be. These are some of the first projects that we tackled, and I'm going to go into details in each one of them. So we'll start with Docker. Docker is one of the tools that we mentioned for the developers. We're basically, what we want to be is in a position for developers to be able to do something like this. Basically say, hey, I want to run something on a specific version of Swift, but I want it to run it instead of on my Darwin-based system, I want to run it on through Docker. In this case, we're just printing the version, but of course you can run a build or run your tests or whatever else you need to do. This is work that was done primarily by the community, so we're very proud of that. Apple, other than giving it a home and giving it kind of like a support, this was all done by the community itself, and it's something that is exciting for us. The work started by Thomas and Harris, and they created the original repo, and Ian Patridge from IBM is taking that over and is now helped host this under kind of like an official place at the Apple org on GitHub, and also publish it to Docker Hub. So that's great collaboration. That's the kind of stuff we want to do with the community. Logging, the logging API was just published, I think this week. We announced it. It's been in the process for a while. We talked about the logging. The most important thing about the logging API that we introduced is the architecture of it. Basically, we separate things between like the API, the logging API, and the logging library. That means that other libraries, other frameworks that you pull into your application as the application owner do not need to know about where you're going to send your logs, right? You can send it to Splunk, you can send it to Elk, you can write it to files, you can do whatever you want with it. But use the application owner determine that, and the libraries that you pull in, they can still log. They can still participate in the party, right? They can give you observability as to what's going on. They do it through the API, though. All they know about is the API. They link against the API, basically. So that's a great architecture that we inherited from our experience in other ecosystems, and we brought into Swift. This is kind of what it looks like to use logging. There's nothing really surprising here. You create a logger, and then you call methods like info or debug, which are obviously the logging levels that you want to use. What is interesting here is that you can see that the logger is mutated. We changed the logging level here, for example. We add metadata. We're making use of the type system of Swift here by the fact that the logger in this case is a value type. So the mutation is on the specific instance that we are using right now. It's not affecting the whole system. We're not changing the metadata for the whole system or the log level. Another interesting thing to see about the logger, if you go into the implementation, is the use of autoclosures. And autoclosures is a way for us to defer the evaluation of the value. In this case, the logging message and the logging metadata. Why is that important? If we were to evaluate what you're logging all the time, high-performance systems would not that would not work for them, because that has cost. So by putting this behind the log level if condition over there, it means that we only evaluate when we have to log. So if you as a server developer, you can say maybe at runtime, now I want to log at debug, and then only we pay the price of the performance. And then you can change that dynamically to error, and then you don't pay the performance. So that's critical for high-performance systems. Next is the metrics API. The metrics API is not published yet. It is still in a proposal phase, and I invite you all to look at it and give your opinions about it. It has very similar architecture. So again, a separation between the API and the actual metrics library. In this case, it's even more obvious. People use various systems to look at metrics, and everybody has their own favorite system. You know, some people like Prometheus, some people like Grafana, some people like something else. It doesn't really matter. That separation of the library from the API allows you to use libraries that emit information, right? If you're using an HTTP library, if you're using a web framework, it can emit different metrics around, you know, how it's behaving in the performance profile, but it doesn't determine where those metrics go. So it's very important. This is kind of like, this is what it looks like. You have these metric object types, and we get into them in a second. And you use them, you initiate one, and you give it a label, and then you basically use it. And the different types that we support are, the first one is a counter. Counter is a very simple metric type. You basically increment on it. You can reset it as well, but typically it's a monolithically incrementable object. So you'd use this for something like, I want to know how many requests are hitting my server. So every request that comes in, you increment by one. The next metric type is timer. You use timer, obviously, to measure the duration of things. So for example, if you're processing an HTTP request, you want to know how long it took you. You would do that through the timer type. What's interesting about the timer type is typically in the implementation of that, you want to also compute things like percentiles or quantiles, where you say, okay, my 95, because performance is not always deterministic, right? Maybe you're talking to the database, maybe it's busy, maybe the machine is busy now, there's peak hours, off-peak hours. So you want to know, like, what's my 99th percentile or my 95th percentile, whatever. So typically in timer implementation, you see this kind of stuff. Similarly, we have a generic metric type called recorder, which also allows you to record arbitrary numeric information. The same way that a timer does, you usually want to see some percentiles. If you use the time series databases, you know, when you see things like histograms, this is kind of like the backing data model for this kind of stuff. And finally, there is a gauge. Gauge is basically a recorder that doesn't aggregate. And if that doesn't parse, then we can talk after the talk, and we can go over this. Database clients, another community effort, which we're really happy to see. Tanner Nelson from Vapor has picked up the glove to drive some of the work around database drivers. And he's taking the Postgres database driver that they built for Vapor, and he's adjusting it to the Swift Neo concurrency model. We talked about, you know, database driver not having a consistent concurrency model and the fact that it is causing issues. So Tanner has worked with the community. They kind of decided that you know, we're going to use the Swift Neo futures and promises as the building block from a concurrency perspective, and he's taking the Postgres database driver and is adjusting it. And you have a link over there to the work that he's doing. This is also like a proposal in process. Similarly, Nathan Harris from the community is doing exactly the same with Redis. We talked about you know, the different database drivers. Postgres and Redis are very popular on the server side. So those were the first two projects. And the beautiful thing is that Nathan and Tanner, they work together. They agree on kind of like the architecture of this. And this is all kind of like emerging work and collaboration in the community. And we're really, really happy to see that and support that. Swift Neo, we mentioned that. It's the networking library that is at the base of many of the server libraries. We just released new versions of Swift Neo HTTP2, and Swift Neo SSL. Swift Neo, the major change is compatibility with Swift 5. That's very important because it's such a low-level library. You need to unblock the rest of the ecosystem from onboarding to Swift 5. So we released that. We also took, obviously, the opportunity, because it's a major version, we took the opportunity to fix a lot of things that we didn't like or we got wrong in the first version. Swift Neo HTTP 2 is a bigger change. What we did there is basically rewritten it. Swift Neo HTTP 2 was based on a C library for parsing and dealing with HTTP 2 payloads. And we came to the conclusion that the performance characteristics of what we're getting from the C library are not what we want. And we took the opportunity and rewrote the whole thing in pure Swift. So that's H2. And finally, Swift Neo SSL. That's also quite a departure from the previous version, and that's an important one for those of you that use Swift Neo and Swift Neo on the server. Swift Neo SSL originally was based on OpenSSL. OpenSSL comes on the machine itself. So it has you have a dependency on the system, right? That comes in Linux. What we did is we switched from OpenSSL to Boring SSL. Boring SSL is a similar library that from Google, but Boring SSL doesn't come on the machine, so we vend it actually in the library itself. One of the cool things that is the outcome of that is that you can now build assembly code with Swift PM, because Boring SSL has optimization in assembly, so we had to work with the Swift PM people to support that. So that's a big thing, and it will help mobility of Swift Neo based applications that use TLS, which is almost everybody. Finally, I want to talk about how to get involved. We talked about the community being important to us. If you are a server developer and you're using some other stack, give it a try, right? Try it out and then join the discussion. Tell us what you think. Tell us where the pain points are, what are the things that work for you. The discussion is happening on the Swift forum, so if you're active there, you can find us. Finally, you can contribute code, right? If this is something that you find interesting. Here are some of the areas where natural for contribution, from database and storage drivers. There's still a lot of work to do there. Logging and metric libraries. We talked about the API. We're going to publish the API, but we also need to work with people to actually write the libraries that will publish the data somewhere. Distributed tracing is something that we haven't started on. Cryptography, if you're into security, is something that is interesting to explore further. And I would like to mention that there's now monthly Swift Linux releases. So I mentioned that the code on Darwin and Linux is not always the same. There's a lot of work going into making it the same or making it complete. And now it's done at the monthly cadence. So that's exciting, and you're welcome to join that. And with that, I'd like to thank you very much.